Of Section 5, long-term series trends and anomalies. And I think Victor will talk about the modeling part of it, and I'll do the data part of it. So, okay, so we had a very good session, a lot of interesting presentations. And today we are in a very fortunate situation in the sense that most of the satellite data, both microwave, passive microwave, and the optical data, Landsat, AVH-RR, they're already at least 30 years long. So, and that's true of also the data sets for snow cover extent and sea surface temperature. So that's excellent. 30 years is a good time, and we can begin to look at trends. So, I made a presentation about trends in NDVI, and there we saw that that there is surprisingly a greening trend all over the globe. Initially, we saw that in the northern latitudes, and so that's interesting. And there was a talk, work by Matthias Forkel, but presented by Dr. Turner, I believe. And so it was essentially trying to explain the trend in the AVH-RR data set about the increase in vegetation, photosynthetic activity. So, and then that was also presented and in some more detail with attribution to climate data by Berger, you will recall. And then Jose Sobrino presented several data sets, both optical and thermal, globally, and for modeling vegetation and looking at trends. And then there was some talk about how to seamlessly go across and intercompare and infer from high resolution data sets by Clevery. There was several, there were a few interesting talks. And this is a new spin of things, and it's very interesting to look at the trends in the drylands. From the carbon perspective, it looks as if the tropical forests were the focus of attention, and they were the big elephant, if you will. But these talks show that the drylands are something that we should be looking at, and there will be a couple of papers coming out very soon, very prominent papers coming out. And in that context, there's the greening in Sahel that needs detection and attribution, careful attribution, because there is two schools of thought, one about changes in land use and another about just climate. So you have heard those talks, very nice. And then there are several poster presentations, given the rich amount of data that is now available. And so there is the phenology, looking at trends in phenology, especially the earlier arrival of spring in the northern latitudes, and droughts. As you know, in the last 10 years, there's been quite a few droughts, and so that's, and trends in soil moisture, terrestrial productivity in Asia, and attribution, and then trends in Arctic vegetation, of course. That's where there's a lot of changes happening. So Victor, you want to add on this?
I will do later.
Okay, so you want me to wrap this up? Okay. So there are, now that we have these 30-year data sets, so obviously we are looking for trends, that's one, detection of trends, and the important problem is trying to explain why these trends are there, if they are spurious or if they actually reflect what is going on in nature. So there is that work that we should do, and attribution is always very difficult, and to do it convincingly would require some creativity and, of course, time. And again, an interesting topic is what 2011 was a very wet year. We had a very strong La Nina. The La Nina was so strong that the Earth's gravity was affected. So, and the dryland vegetation bloomed, and I believe they detected the strongest terrestrial sink in 2011. So, and it looks like the dryland vegetation played an important role. So it is a very interesting finding. And of course, we are very much reliant on satellite data for looking at these trends, and that always raises the question of how valid are these data sets, and that won't ever go away because you're sitting in your office, the satellites are flying there, so trying to infer something from those instruments is always tricky. And my friend Jim Tucker always says that you need to somehow tie it down to something that you can measure on the ground, but that is always challenging. So finally, a few recommendations. Obviously, there is a lot of activity, and we should continue to put pressure on the powers to be that they provide the support that's required for collecting and assembling these data sets. To give you a very real example, Jim Tucker at NASA Goddard, he's been instrumental for several years in developing that NDVI data set, and he has no funds, and he was losing personnel, and NASA would not fund him. And so he throws a tantrum, and he says, I'm not going to distribute the data. And so a lot of people every day, I get 2-3 emails. For some reason, they write to me asking me for the data, and Jim said, don't distribute the data. So there are serious issues, and it's this is something that we need to continuously work on, because agencies like NASA, they say that we are technology demonstration agencies. We don't fund long-term data set developments and so on and so forth. If they don't do it, there's nobody else who will do it. And you all can realize how important these data sets are. So clearly this meeting is very successful, and that's the feeling I have, and I'm sure having talked to several of you, I get the same feeling. And I think Fred is to be commended, and the other organizers, Murray and others, who may have worked behind the scenes to bring together remote sensing and modeling communities. That's really excellent. I've been in the last 20 years to a lot of remote sensing meetings, and I slept through most of them, so it's an excellent meeting. Hear all the modeling talks, and I learned a lot personally. And clearly we need to focus, there are some regions which are very interesting in the sense that the changes are happening there in a dramatic fashion in our lifetime. So the Arctic is an example, and there is a focus, and we should be doing and emphasizing those areas. And I mentioned the drylands, which is coming up. So you will hear more and more, read more papers on those things. So with that, I stop and let Victor elaborate further.
I will add a few remarks from the modeling side, because I'm a global scale modeler, and actually I'm a really newcomer to this remote sensing analysis and using in the models, because all my previous scientific life I worked on a much longer time scale, so going to Quaternary, going to the Holocene, to the glacial cycle, looking what will be in 10,000 years from now. So and for me, 50 years of observation is not very long period. So that's something I also have to learn here. But I was really surprised how much joint work is now between modeling and remote sensing communities, because we really try to integrate the data into the models. One of the interesting aspects which always strikes me is that right now when we see this greening trend in the data, we also have this greening trend in the models, but mostly due to CO2. And that's why I was a bit asking several times on this issue, but we don't know exactly whether we get in the model the right result for the wrong reason, but it's still the right result. And also if you look for drylands, we also get an increase in woody cover in most of the models also in the future. Again, looks like for present day it's a correct result, but is it really valid for the future? Is it really right relationship? So that's something I think where we can do much more, also together with remote sensing communities, because we need to look to attribute what are reasons for these changes in both vegetation cover and also in woody cover. I think that's very important, and of course great it will be if we don't use model for that. So if we can do attribution studies based only on the remote sensing products, that would be great. Another issue I want to add is that, of course, this 30 years period, if you look at a much longer time scale, is very short. So, but we have a lot of proxy data, for instance, for the last 1,000 years of the Holocene. And what is also important is to integrate somehow this rather short satellite period of observations to the whole record of our history, let's say for the last several centuries, then for 1,000 years, and then probably for the Holocene, because there are many fascinating questions on the onset of the Holocene, how human society have developed and how this changed the climate and environment. But for that we also need a compilation of the data on much better level than we have now. So that's all from my side. Thank you.
Any questions? Long time series. A short question.
No questions at all.
We are on time, so. Okay, thanks.